How many times have you written a test, only to realize you missed obvious edge cases that broke in production? You'll see how, at Pytest, parameterized turns a single test into a battery of checks, running the same logic against multiple inputs with zero extra boilerplate. We'll use it to verify a FastMCP tool's math operations, ensuring every input-output pair behaves exactly as expected.
Import Pytest. From my project main, import MCP. From FastMCP client, import client. From FastMCP client transports, import FastMCP transport. At Pytest Fixture. Async def main MCP client. Async with client, MCP as client. Yield client. At Pytest, mark parameterize. First number, second number expected. 1, 2, 3. 2, 3, 5. 3, 4, 7. Async def test add. First number, int. Second number, int. Expected, int. Main MCP client. Client fast MCP transport. Result equals await main MCP client. Call tool. Name equals add. Arguments equals x. First number y. Second number. Assert result data is not none. Assert is instance. Result data int. Assert result data equals expected.
This demonstrates the fixture pattern combined with parameterized testing for RPC service validation. The approach creates a reusable test client fixture that encapsulates server connection logic, while parameterization enables testing multiple input-output scenarios against the same endpoint. What makes this distinctive is how it separates test infrastructure from test cases, allowing you to focus on behavior rather than setup. The pattern works by establishing a clean boundary between test configuration and execution. The fixture handles the async client lifecycle and server connection, while parameterized test cases remain simple assertions about expected behavior. This separation enables declarative test definitions where you specify what should happen, not how to set it up, making tests more maintainable and easier to extend. This approach matters because it solves the dual problems of test boilerplate and coverage. By centralizing client setup in a fixture, you avoid repetitive connection code across tests. Parameterization then lets you validate edge cases and happy paths with minimal additional code. The trade-off is slightly more complex initial setup, but the payoff comes when adding new test cases or modifying server behavior, where changes propagate automatically to all parameterized scenarios. Let's break it down line by line.
Import Pytest.
Imports Pytest, the standard Python testing framework. This enables parameterized tests, fixtures, and async test support used throughout this test suite.
From my project main, import MCP.
This imports the MCP instance from your project's main module, which serves as the central FastMCP server connection point. It's the entry point for all tool registrations and client interactions in your application.
From FastMCP client, import client.
This imports the client class from FastMCP, the primary interface for interacting with MCP servers. It enables tool calls, connection management, and response handling in a single unified interface.
From FastMCP client transports, import FastMCP transport.
This imports FastMCP transport, the concrete transport implementation for FastMCP client-server communication. It defines how data is serialized and transmitted between the client and MCP server, ensuring reliable async message passing.
At Pytest Fixture. Async def main MCP client.
This is Pytest's fixture pattern for reusable test setup. It creates a shared MCP client instance with automatic connection cleanup after each test, eliminating resource leaks. The Async definition matches our test suite's Async requirements.
Async with client, MCP as client.
This establishes an Async context manager for the FastMCP client connection. The pattern guarantees proper resource cleanup after each test, preventing connection leaks. It's the Async equivalent of Pytest's fixture setup teardown pattern.
Yield client.
This is Pytest's fixture pattern for reusable test setup. The yield client temporarily hands control to the test while maintaining the client connection, then ensures proper cleanup after the test completes. This eliminates connection leaks between tests while avoiding repeated setup code.
At Pytest, mark parameterize. First number, second number expected.
This uses Pytest's parameterized decorator to run the same test with multiple input combinations. Eliminates repetitive test functions by defining inputs and expected outputs in a single table. The test will execute once for each tuple in the list. Verifying the add tool handles all cases. This opens the test data list for Pytest. Mark, parameterize. Each inner tuple defines one test case with inputs, first number, second number, and the expected result, enabling the same test logic to run against multiple input combinations.
1, 2, 3.
This is a test case tuple for parameterized testing. It defines the inputs 1 and 2 and expects their sum 3 as the correct output, verifying the add tool's basic arithmetic functionality. The pattern enables testing multiple input combinations with a single test function.
2, 3, 5.
This is a test case tuple in Pytest's parameterized pattern. It provides the inputs 2 and 3, expecting the add tool to return 5, verifying basic arithmetic correctness. The pattern efficiently tests multiple input combinations without duplicating test logic.
3, 4, 7.
This is the third test case in the parameterized test, verifying the add tool handles the input pair, 3, 4, and returns the expected result, 7. It follows the same pattern as the previous cases, ensuring consistent behavior across different input combinations. The parameterized decorator runs the same test logic with all provided input-output pairs, eliminating repetitive test code. This closes the parameter list for at Pytest. Mark, parameterize. It defines 3 test cases for the add function, each with 2 inputs and the expected output, enabling comprehensive input validation with minimal code. This closing parenthesis terminates the at Pytest. Mark, parameterize, decorator's argument list, finalizing the 3 test cases for the add function. It enables Pytest to generate 3 separate test executions, one for each input-output tuple, without duplicating test logic. This is the parameterization pattern for data-driven testing.
Async def test add.
This defines an async test function, required because we're testing async code that interacts with FastMCP. The async def signature enables await expressions inside the test, allowing us to properly test the asynchronous call tool method. Without this, Pytest couldn't handle the async operations in our test logic.
First number, int.
Type annotation for the first test parameter. Enforces integer input, enabling Pytest to validate test cases and generate clearer error messages if non-integer values are provided.
Second number, int.
This type annotation enforces that second number must be an integer, enabling Pytest's type checking and providing clear documentation. It prevents accidental passing of non-integer values that would break the addition test logic.
Expected, int.
Type annotation for the expected result enforces that test cases return integers, catching type mismatches early. Pytest uses this to validate parameterized inputs match the expected signature.
Main MCP client. Client FastMCP transport.
This type annotation specifies the client uses FastMCP transport, ensuring type safety for all transport-specific operations. It guarantees the test only receives properly configured clients, preventing runtime transport mismatches. This closing parenthesis terminates the testadd function definition and its parameterized inputs. It marks the end of Pytest's parameterized decorator configuration, allowing the actual test logic to begin in the following indented block. The pattern enables running the same test with multiple input combinations efficiently.
Result equals await main MCP client. Call tool.
This invokes the FastMCP tool named add with the provided arguments. The await handles the asynchronous RPC call to the MCP server, returning the tool's execution result for validation. This is the core test action. It verifies the tool behaves as expected with different inputs.
Name equals add, arguments equals x. First number y, second number.
This specifies the tool name and arguments for the RPC call. The name equals add identifies which FastMCP tool to invoke, while arguments passes the test inputs as a dictionary, matching the tool's expected parameters, x and y. This mirrors how AI models would call the same tool with structured input. This closing parenthesis terminates the @Pytest. Mark, parameterize, decorator, finalizing the 3 test cases for the add function. It enables Pytest to generate 3 separate test runs with the provided input-output pairs, verifying the addition logic against each scenario. The pattern eliminates repetitive test code while ensuring comprehensive coverage of the core functionality.
Assert result data is not none.
This assertion validates that the RPC call returned actual data, not none. It's a basic safety check that defeats silent failures where the server might return no response, ensuring we're testing meaningful results.
Assert is instance, result data int.
This runtime type check enforces that the tool returned an integer, not a string or float. Prevents silent type coercion bugs where 5 or 5 might pass a loose equality check, but break downstream logic expecting strict integers.
Assert result data equals expected.
This final assertion verifies the tool's output matches the expected result. It's the core validation that confirms the add tool correctly implements the specified behavior, catching any logic errors in the implementation. FastMCP Async testing pattern. The Pytest fixture pattern with Async clients creates a clean testing boundary, automatically handling connection lifecycle while keeping test logic focused on behavior verification. Omitting the Async keyword on your fixture will silently fail with event loop errors that appear unrelated to the test setup. This approach scales from unit tests to integration tests without changing the core testing pattern.
The test that never awaits, awaits forever.